All right, pass the assignments this way, I'll collect them. Now, on that video that I showed you, the online explanation on how to do the standard error, if there's an easy way to do it, you know, the equals STEYX, that's great to have that tool, but the first time you do something in a homework assignment, I hope you'll do it sort of the manual approach. And this will come up again where there will be a really easy function that solves everything for you without you having to do any work. And it's okay for you to use that after you've done it the manual way to verify what you've done, but I would like you to get some practice doing things the hard way, just so you know how to do it. So your next homework assignment is going to be due on Wednesday. Let me hand that out to you. Oh, wait, is that the wrong one? We're not having a quiz today. I think it saved the changes that I made. Maybe. There's no quiz today. Sorry, that's a typo. We've already had quiz number 2, right? Yeah. All right, so I've collected homework 3, homework 2, homework 3 is due on Wednesday, and we're talking about chapter 4 today, which is really the heart of the course. This is probably one of the most important sections of what you'll learn in engineering economy. So before we dig into it, any questions on the announcements or concepts from previous lectures you want to ask about? Andrew?
And midterm on Friday. So we need to know the all those equations, or
Which equations?
we've done the weight value, the index, all the formulas. I mean, do we need to have all those memorized?
You don't have to have them memorized. You need to know.
Well, I know how to
You
use
need to
them.
know how to use them, yeah. So on the midterm exam, there's going to be 2 parts. There's going to be a closed book, closed note part, where I'm asking you conceptual questions and terminology and definitions. And then there will be a part that's open note. And so you can use the notes that I've printed out for you. You can use an equation sheet if you prepare that. You can't use the book, but besides that, you can use the notes and an equation sheet that you can prepare. Yeah.
So you can use anything in your notebook, like you can use existing homework, so you've got back and quizzes and stuff like
Yeah. Other questions?
that. Did you use Excel?
There may be a question where I ask you to use Excel specifically, yeah. And so if you prefer to use your own computer, then bring it with you on Friday. Otherwise, I'll just open up the tablet card and have access to that. All right. So the relationship between money, time, and value is really a lot of importance in engineering economy because quite often, especially in civil engineering, which some of you are, the projects that we construct have a very long lifespan. And so in order to recoup the cost of the project, you're going to have to be gathering revenue for a long time. And it's important for you to know whether an expenditure can be justified by revenues in the future. And it's hard, without understanding the time value of money principles, to have an idea of how much that revenue in the future compares to expenses that are incurred now, because the value of money changes over time. So before we get into that, just a refresher on a couple of terms. This has come up in the previous chapters, and so let's distinguish between direct costs. Direct costs are when you can attribute an expense to something that has an output that you're going to sell, whether it's an object or a service, and you can trace it directly to a unit output of that. And so in the case of a company that produces furniture, then the wood is direct cost, so is the person who's actually shaping the wood into furniture. But an indirect cost is something that it's more difficult to trace to the direct output of what's being sold. And so taxes, administration, and so the way that you can sometimes distinguish between the two is whatever's being sold, you can say how much of, and then if it's taxes that you're trying to classify between direct and indirect, you can say how much taxes does it take to make a chair. And there is no, the taxes don't go into chairs, but labor goes into chairs, wood goes into chairs, upholstery, fabric. And so how much administration goes into making a chair? Don't know. Security. And so you can divide up these costs and find out, if you're making 1,000 chairs in a month and you know what your security costs are, you can allocate it on a per item basis, but it's not really a direct cost because in a different location it maybe would require different security costs or different administration. But where if you were to move locations, it still may take the same amount of wood for the item that's being produced. And then classifying fixed versus variable costs. Fixed costs are those which don't vary depending on how much is being produced, rent, for example, but variable costs are volume related. And so the more activity there is, the higher the variable costs are going to be. And so I just wanted to reemphasize those definitions. Okay, so what is money good for? What's the use of money?
Buying things?
Okay, buying things. What else?
Bribing people.
Bribing people. All right, have you had to bribe a lot of people at Marshall? Hopefully not. All right, so the first thing is as a medium of exchange. Think about the alternative to money. If we had to directly trade what we produced with people who wanted what we produced. And so what I produce is lectures. And so what could you pay me with? What do you produce that you could pay me with if we didn't have an intermediate exchange of value? Like bracelets or something, or maybe students are sometimes cleaners or delivery people or laborers. And so if we didn't have money, makes it easier for you to give your services to whoever wants them and then to transfer the value of those services to a third party so that it doesn't have to be a direct transaction. And so sometimes what I always think is really funny is when you're on Craigslist and someone says, like, wanted front bumper for a Mustang, 1998 Mustang, willing to trade old washing machine. It's like so specific. It's like they're posting on Craigslist and they think that they're going to find someone who has exactly what they want and is willing to take exactly what they're willing to trade. And I mean, you could sort of understand it if it was a commodity item. Like if it's someone who's saying wanted shotgun, willing to trade firewood. Well, a lot of people use firewood, or wanted flat screen TV, willing to trade gasoline. Gasoline's as good as cash almost because everybody uses gasoline. But then it's never like that because the people who want to do these trades wanted PS3 controller, willing to trade duck eggs or something.
I'd love to find someone that's just like, how do you wash it, Jay?
Yeah.
I just have this front bumper out in the yard. I don't know what I'm going to do.
Well, post on Craigslist because, I don't know, it must work or else people wouldn't do it. Okay, so bartering is the alternative of that. Another option is someday you're going to earn more money than you actually need. And I know that probably seems a long way off, but at some point your income is going to exceed your expenses. So when that happens, what are you going to do with the excess cash? Are you going to throw it in a hole? Are you going to burn it to keep warm? What do you do with the excess cash? Gamble? All right. All right.
Investments.
All right, why? Why are you going to invest in it? To make more money, but why? You are already making more income than expenses.
For when you don't have income.
Okay. So part of the purpose of money is as a store of value. Okay, so let's go back to the idea of what if there wasn't money. So if there wasn't money, we'd have to do bartering, direct bartering, which would be very inefficient. If there wasn't money, what you have to do is you have to store up what you did so that when you were old and decrepit and couldn't do it anymore, you'd have enough stored for you. And so if I was a lumberjack, I'd store up, all my life, I'd store up firewood every season, put a little bit extra so that when I retired, I'd have enough firewood stored up so that in my old age years, I could have something to burn and keep warm. And then maybe I could barter the firewood for duck eggs when I need duck eggs. So, obviously, whatever you're doing, probably the output of your work isn't going to store directly. Farmers have an easier way of storing the value of their labor than someone who works at a call center. What's the store? How would you, if it wasn't for money or some other instrument, monetary instrument, you wouldn't have a way of storing your value for later on down the road, from season to season, from year to year. So that's another purpose of money. And the third purpose of money, which is a little bit more abstract, is as a instrument for accounting. So it's a way of just keeping track of who's doing what. Having money available tells you which U.S. states have more economic activity. Having money available, it's an indicator of poverty. You can use it just to understand what's happening in an economy and in a society. And if there was just bartering and people storing their value directly, then you really wouldn't have an idea of what's going on with the economy and where people were poor, where people were productive, and so on.
That's sort of an audit on like the lumberjacks would.
A lumberjack audit, maybe. But then how would that auditor get paid? Through lumberjack wood? Maybe. The tax. So I guess it's a good thing. They say that the money is the root of all evil, or is it the love of money is the root of all evil? I don't know which it is, but it sure would be inefficient and inconvenient if there wasn't money. You'd have to be an expert at a lot of things. You'd have to manufacture your own car or find someone who is willing to make the car for you for whatever you could do. Really inconvenient. So capital is another word for money, and it is the wealth that can be used to produce more wealth. And this is kind of a funny thing that I've always been a little bit amused at, is a lot of people refer to their home as an investment. And so the definition of an investment is something that can generate more wealth. And by that definition, a house is a really awful investment because it doesn't generate wealth, it consumes wealth. It costs a lot of money to maintain a home. You have to pay taxes on just the ownership of it. Whereas if you had $100,000 in the bank, you don't pay tax on the property itself. You may pay tax on the earnings, but not on the property itself. And so $100,000 invested in land, you're going to have to pay 1% property tax or whatever it is in the area that you're living. But the true definition of capital is something that can generate more money for you.
I would look at a house as like an investment more. It was just a really like a savings account. That
Okay.
Will, real estate's always pays you back.
It may not pay you back
Not at all.
if you own it for other people to live in it. But let's say if it's for you. I think of it as a way of minimizing expenses. Because over the long term, if you own your own property, even paying the property taxes is going to be less than paying someone else to live on the property that they own, because they're going to have to recoup all of those same expenses and then also try and make a little bit of money off of you. The same is true of insurance. If you own a car, you have to have liability insurance. That's the law. But then the comprehensive and collision, what they're doing is they're taking money from you because they've calculated the probability that you're going to crash your car. And so they're saying, I'm willing to take $100 a month against the odds that you'll crash your car this month. If the odds were greater than, let's say if you've got a $10,000 car, and they want $100 per month for insurance, then what do you think the probability is in their mind that you're going to get into a crash? So it would be, they're saying 1 in 100 probability, for break-even odds. I think there's less, in my case, I think there's less than 1 in 100 probability. I think that I'm a safer driver than that, so I don't carry comprehensive and collision on my car. Just because I think, well, if I get in a crash, I'll just buy myself another car. I don't need the insurance company to do it. And built into that also is they have to make a living. You know, they have to pay the administrative costs and the commission for the insurance agent and everything. And so it's a little bit, insurance is a little bit like an investment against not having to pay it yourself. And so I guess the analogy here is buying a home versus renting. You have to look at whether someone's going to be making a profit off the activity and whether you think you can do it cheaper than them giving it to you. So that's a little bit of a tangent, but there are two ways for you to, two big ways for you to deploy your capital to make money. You can either become a part owner in a business, or you can loan a business money, or you can you give someone a personal loan, or you can be a part owner in whatever their idea is. And equity is a word that's sometimes used for investments like stocks. And so in a stock investment, what you're doing is you're purchasing shares in a company, and by purchasing those shares, you have a claim on their future earnings. And the expectation is that sometime in the future, or maybe even now, the company is having more income than their expenses, and so they'll either accumulate cash in their own company accounts, or they'll pay a dividend. So in equity, you are becoming a partner with the organizers of the company, and in debt, rather than being a partner and getting a share of whatever their returns are, they're taking some of your money with a specified rate of return. So in equity, in theory, you could really make a lot of money if it turns out to be a highly profitable business. But in debt capital, when you make an investment or a loan to someone on a debt basis, there's an upper limit of how much you can get back. It's just the interest rate that's specified when you make that loan. So which do you think is less risky? Equity capital or debt capital? When you loan someone money as a loan, or when you purchase their stock? Which do you think is less risky?
Yeah.
Why is that? You're right. Why?
Because you're almost guaranteed to get your money back. I mean, depending, it's just like person to person, it's probably not, but as far as businesses go, I'm sure, or banks.
Okay. Debt is oftentimes, almost usually, always, secured with some sort of collateral. Whereas equity, you don't have any guarantee of returns. And so you're taking a risk just like the company is taking a risk. If their business fails, then you get nothing in the case of equity capital. But in debt, it may be secured by property that the business owns. It could be secured with their equipment. And so debt is less risky than equity. And as a result, over the last 100 years, generally there is a greater rate of return for equity capital because it's a higher risk. There's a better rate of return. But if you have a shorter investing time frame and you're not able to accept a greater level of risk, then debt can be a better investment. Another interesting issue is that the return that you get for equity versus debt is taxed at different rates. If you invest in the stock market and you get dividends from a company, then those dividends are taxed at 15%, which is a very low tax rate. But when you invest in a debt instrument, the returns you get are just taxed as ordinary income. And for very rich people, the upper marginal tax rate of ordinary income is about 40%. So 40% versus 15% tax is a big difference. So you may have heard that one of the big issues with the presidential election, Mitt Romney is a very wealthy individual, and some people were outraged that he pays so little in taxes. And the reason why he pays so little in taxes is because most of his wealth is invested as his equity. So he owns stocks and is getting dividends, and dividends are taxed at a low rate. We're going to talk a lot about interest over the coming weeks. And so interest is defined as the fee that a borrower pays for the use of money. You're temporarily using the money, and you're not only going to return the amount that's borrowed, but then also some extra. So interest rate is the percent basis when you compare the amount that's borrowed to the amount that has to be the extra that's paid back on an annual basis. And so there are a lot of different types of interest rates out there, and let's look up some of them online just to get a sense for what the typical rates are these days. There's a website I like to look at called Bankrate that we'll be able to use on some of these. So the first thing we're going to look up is interest rates on a savings account. What's a bank here in town, by the way? Like Huntington Bank, for example, we could probably find out what Huntington Bank is paying and then see if on Bankrate we could do a little bit better. Coming up slowly. Meanwhile, oh, here it is. Huntington Bank. So still loading. Wow. Savings rate 0.05%. That is really, really terrible. 0.05%. Just for a little bit of, wow, that is so low. Just as some perspective, when I was in college, when I got married, we got some money from gifts, and we were able to put it in a savings account that was paying 5.6% interest. And so that interest was 100 times more than that. That's really low. All right, so if we go to the Bankrate website, we can probably find something better than that. We'll go to savings. Huh?
They like advertise how bad.
Yeah, they're so proud of that. They got that in big letters.
What's the asterisk mean? Top 10 online. It's up at the top.
Annual percentage yield. It's depending on balances, I guess.
It's set it up higher.
Oh, you get 0.1% if you save $20,000. So that goes you
I just have
up.
that laying around and I want to stick it.
Yeah. So we'll sort by APY. It looks like there are banks out there that are doing better. Everbank, Barclays, 1%. Huh? These are probably online accounts. But you can see that's still pretty bad, 1%. Inflation is more than that. So really, if you have $100 and you put it in that bank account, the cost of goods is rising faster than the interest you're going to pay. And so your real rate of return, when you consider the fact that inflation is more than 1%, is negative. You're going to be losing value because the cost of things that you want to buy is increasing faster than the interest that you earn.
What about fees?
Fees?
National Bank.
Which one?
The Huntington National Bank. The 0.05.
Yeah.
You didn't say anything about fees.
Oh, let's see.
Probably have to have a
Fees may reduce earnings.
Yeah. If you make too many withdrawals on a savings account, sometimes they'll hit you up with a fee. All right, CDs. Now, what's the difference between a savings account and a CD?
CD, you can't get your money out. It's specific to how long your money stays in.
Right. So a CD is called a certificate of deposit, and how much you earn is a function of how long you're willing to let it sit there. And so if we look at for 1 year CD, 1.08. So that's already better than the 1% we saw for the savings account, because what you're promising is you're promising to leave it in there for a year. And so that allows the bank to make investments over the longer term and that they may not be able to make if they had to be worried about you taking your money out at any time. So we'll look at a 2-year CD. A little bit better, 1.2%. The longer you leave it in, the higher the CD rate is, 1.75. So we're almost at the break-even point. I think inflation nowadays is between 2 and 3%. There is a risk of it going quite a bit higher, though.
Now, did you get that savings account locked in at that percentage rate?
Back then,
Yeah.
way back when? No.
Because you'd be rocking right now.
Yeah, yeah, I did have some CDs that were locked in, and in fact, CDs, they're all manner of really strange CDs. Everbank, which is one of the ones that were listed there. Some of the Everbank CDs aren't tied to a percentage rate, but what they'll do is they'll say, you have to leave your money in for, let's say, 5 years, for example, and then they tie it to the performance of some benchmark. Let's say the price of gold. And so if the price of gold goes up, you'll get maybe 50% of how much it went up. But if the price of gold goes down, then they'll say you get nothing. I've had one of those CDs before. Let's see if we can pull up, see which ones they've got available right now. I think it's in there.
If you only get 50% of the price of gold, then you just buy gold and you get 100% of the price of gold coming out.
Market safe CDs, yeah. All right, so we talked about savings accounts, CDs, car loans. Well, certainly car loans are going to be about the same as the 1 or 2% that if it's a 5-year, so 5-year CD, they'll pay you 1.75, then it must be the same if it's a 5-year car loan, right? It's going to cost 1.75. Let's see, auto loans, 60-month new car, that's a 5-year.
They don't have the 72 one?
West Virginia, Huntington, let's see how much a 5-year.
72.
Boy, this is pretty good. 1.99 if you go through Pentagon Federal, but the local banks in town are charging between 3.4, 4.7, and I imagine that's also based on your credit rating. People with a credit rating that isn't as good are going to have to pay a bigger rate of interest rate. Home mortgages, we can get the mortgage if you want to buy a house, mortgage in West Virginia, Huntington. If we were going to buy a $100,000 house for 30 years. All right, so 3.7, 3.8. Now's a great time to buy a house. The interest rate on homes has really never been this low. Credit cards. Anybody know what a typical credit card interest rate is? 17 or 18%. Yeah, credit card rates are really, really high. I don't know if bank rate ends up having credit card rates. Credit cards. Let's see what a so-called low interest card rate is. Okay, the introductory APR is 0, but then after that, 12 to 22%, 12 to 20%. 12% looks like a pretty common minimum. Sovereign debt. What does that mean? Anybody know what sovereign debt is? It's the interest rate that countries have to pay in order to borrow money. And so the United States, let's say U.S. Treasury rates, if the United States wants to borrow money from people, if they want to borrow it for 10 years, they'll pay, it looks like these are rates that are determined by auction. They will borrow money from whoever is willing to loan it to them for the lowest amount. And so they have auctions. 2% per year for 10 years. So that's pretty low. The government gets good terms. The U.S. government has pretty good collateral. Do you know what the collateral of the U.S. government is? They do have some gold, but they've got a much more valuable collateral than that. They have the ability to tax the richest economy in the world. They have the legal right to levy taxes on a very productive and vibrant economy, and so that's why they're able to borrow money at really good rates is because the value of America is high, and because they haven't defaulted before. Look at this 1 year, 0.19%. That's crazy. What about other countries?
Denmark.
Who Liberia or something?
Let's look up Germany.
That was
Germany.
like,
South
that was
Brazil.
no, that was Syria.
South America.
No, it was.
All right, these will be good. This will be good for a laugh.
My sister lived there.
Okay, so Germany, for 10 years, 1.75, really good interest rates for Germany. There are, it jumps around a little bit, it looks like. I don't know why it would go from 0.5, coupon. We'll talk about the difference between coupon and the actual interest rate. Huh?
Think about the countries using coupons for interest rates.
Yeah, what that means is that when you buy a bond, it says on the bond what the interest rate is, but sometimes they're sold on a secondary market, so that I'll buy a bond not directly from the government, but I'll buy it from another person. And if interest rates have changed since that auction, then I may not pay the full face value. Maybe it'll be a $100 bond and it'll say 2%. But if the interest rates are higher now, then a bond that pays only 2% isn't worth as much. And so maybe I'd only pay $90 for that $100 bond, to take into account that interest rates have changed. Germany has really low interest rates on its money. You may have heard that Greece has had some financial problems lately, and during the depth of their financial crisis, their bonds were selling for 20–25%, really bad. Italy and Spain are having some trouble raising money these days, and so one of the big recurring news items that is in the newspaper almost every day is the financial crisis that still persists in Europe, and how the European Central Bank is having to buy the bonds of individual countries to try and keep the interest rates low. Because remember, it's determined by auction. And so when investors throughout the world aren't interested in buying Greek debt, then the European Central Bank has been buying the debt so that the auction doesn't go too high, so that Greece doesn't have to pay too much for its borrowing. And so this figure illustrates that relationship between demand and interest rate. What it shows is that when there is a lot of money, the quantity of money is high, meaning there are a lot of banks willing to lend money, and interest rates are low. Another way of thinking about it is when there's a low demand for money, there's a lot of money available to be borrowed. And so part of the reason why interest rates are low right now is partly because the government has been making money available to banks. Banks borrow money from the government and then they loan it to people. They act as a middleman. But also a lot of businesses aren't expanding right now. There's an uncertain economic environment, and so a lot of businesses aren't expanding, and so they don't need a lot of money to retrain people or build new factories. And so right now we're at the point where there's a lot of money, there's a lot of supply and not very much demand for money, so the interest rates are low. But if there was more demand for money and the available supply that can be loaned out decreased, then you'd notice that the interest rates would go up. And that's where we were at. When I was getting the 5.6% on a savings account, it's because the economy was doing really well. Businesses were having to compete for the ability to borrow money, and so there was very little supply of money. And when I was putting it into a bank, I was adding to the available supply, and interest rates were very high at that time. So there's a relationship between interest rates and supply in the same way that there was a relationship that we looked at for price versus demand early in the semester. So how do we calculate the amount of money that's going to have to be repaid? The simplest way to structure the terms of a loan is what's called simple interest. And so the total interest that's paid is proportional to how much is initially invested, P, the annual interest rate, I, and the number of periods that the principal is committed. So sometimes interest accumulates on a monthly basis, sometimes it accumulates on an annual basis, but N is talking about how many periods it accumulates during the course of the loan. So let's consider what would happen if $1,000 is borrowed at 10% annual interest rate for 5 years. What's the total payback? So no payments are made till the end of the loan term. So there is an interest that's being paid over time. So the interest that is going to be paid is the principal, 1,000, times the number of payments, 5, and then the 10%, 0.10. So that should be $50 per, 10% is going to be $100 a year, so $500 is the total interest. And then what is the total payback will be the principal plus the interest. And so you'll have to pay the original 1,000 that was borrowed and the $500 interest, so $1,500. Okay. What about compounding? What compounding means is that not only do you have to pay interest on how much was borrowed, but you also have to pay interest on the interest. And so if you're borrowing money, this can really hurt you, and if you're saving money, this is a helpful thing. And so think about it in a credit card. If you buy something on a credit card and you only pay off some of it that month, then the next month, not only do you have to pay interest on the original item that was purchased, but you also have to pay interest on the interest they charged you the first month. And so it can be very expensive. Or if you're saving money, let's say that, back when I had that 5.6% savings account, they didn't actually give me and force me to walk out of the bank with the interest each month. I just left it in that account. And so that the next month, they paid me interest not only on the original amount that I put into the bank, but they also paid me interest on the interest that I'd earned cumulatively before that. So here's the formula that shows us how we can calculate the interest that's paid when it compounds. So let's look at this example. If it compounds annually, so it's the same $1,000, and we have, again, an interest rate of 10%, but it's compounded annually. So what's the total payback? So the interest that we're going to have to pay is $1,000, which is the principal, P, times 1 plus I, 1. And here's the thing. Okay, compounded annually. So that is the interest rate per period is 10% to the n, 5th power, minus the 1,000. And so we'll calculate the interest amount here is $610.51. And so then the total payback would be the original $1,000 that was borrowed and the $610.51 in interest. So 1610.51. So why is it more?
Could you just leave the minus 1,000 off at the beginning and then give you the final answer?
Yeah, but this is the formula for the interest. So if you wanted to know I plus P, yes, you move that over to that side of the equation.
Right.
So the interest in the first example was 500. So this time, instead of 500, it's 610.51. So Aaron, why do we have to pay an extra $110.51 this time?
Because you're charging interest on the previous year's interest now instead of
Right.
all at once.
Yeah, what they're saying is, well, if you didn't want to pay this extra $110.51, you should have paid me the interest every year. But we didn't. We let it ride to the very end. And so it's sort of like, at the beginning we owed $1,000, but then at the end of year one, we owed them $1,100. And so between year 1 and year 2, they charged us 10% interest on the $1,100 that we owed, not just on the $1,000. All right. Okay, what about this? What if it compounded monthly? I'd like you to calculate this example. We'll put the formula on the board here. If it just compounded on a monthly basis instead of annually, what that does is it changes n. N will be 60, because the definition of n is how many compounding periods there are. And so if it's compounding monthly and there's 5 years, that means there's 60 compounding periods. And I, the definition of I isn't the interest rate per year, it's the interest rate per compounding period. And so I is going to be 10% divided by 12. So you can use that same formula and calculate how much the interest is and the total repayment if it compounded monthly instead of annually. So try that. Our formula again is I plus P plus 1 plus I to the N minus P.
See that?
Plus up there, but it's usually plus 3 times. That's one. No way.
Yeah, it's 6:45.
Yeah, we did this in Pearson's class also.
We do this in physics too.
Oh yeah, I forgot about that.
And I had this in Southern, so I should explain.
Okay, Charles, so what is I?
645, 31.
Okay, so that's the big I is 645.31. Exactly right. So what about the interest rate per period? 0.00833. Okay, N is 60, right? So the $645.31 in interest. So that's more. In the previous example, when it was compounding annually, it was 610 over the whole period. If it's compounding monthly, 645. So we can calculate the effective interest rate when we take into account the effect of compounding. And so they said that it was 10% interest rate, but what is the effective interest rate? In this case, the interest rate effective is 1 plus 0.10 divided by 12, 12 minus 1, 0.1047. And so 10.47% is the effective interest rate on an annual basis if you consider the fact that it's compounding monthly. And so that takes me back to what we were looking at on bank rate. Let's look at the savings accounts. How about for
Credit cards are daily. Yeah, daily.
credit cards? Yeah, they'll sometimes compound daily. Yeah. Oftentimes, I'm not seeing it. Okay, here's an example right here. The difference between rate and APR. So sometimes they'll quote you what the rate is. This is the annual interest rate. But when you take into account that it compounds monthly, then on an annual basis, the actual interest rate is 3.4%. And so the bigger the interest rate, the bigger the difference between the actual and effective interest rate will be. So that's something you have to be careful about, is that when they quote the APR, that can be showing you the effective compounding. Any questions so far about this? Okay, cash flow diagrams is why you bought that special paper. It's so that you can draw diagrams of when money is saved and when money is borrowed. When money is used and when it comes back. When we construct a cash flow diagram, we have some of these terms that we've already talked about. I is the effective interest rate per period. N is the number of compounding periods. Now P, or sometimes in the text is called PV, that's referring to the value of money at the present time. We're going to create diagrams that convert money in the future, F, or FV, to the present. Or we'll convert money in the present into future values. An A is when we find out how much money on an annual basis, or it doesn't necessarily have to be annual, it could be, A stands for annual, but it could be a periodic recurring payment in a uniform series, and G is a gradient, so that maybe in month 1 you'd have to pay $100, month 2 you'd pay $200, month 3 you'd be $300. So we're going to be converting between all these different possibilities. Money now, money in the future, money on an annual basis. And so we'll look at a couple of diagrams that help illustrate that. So a man borrows $1,000 from a bank at 6% interest compounded annually for 5 years. Draw the cash flow diagrams for the following payback scenarios. A single payment at the end of the 5th year would look like this. So we have a line, 1, 2, 3, 4, 5. All right, so we would have down, anything down is an expense or money out. Anything up is money in. So we're going to do from the point of view of the man. So the man's point of view. All right. So the man borrows $10,000 at the beginning. So that means he gets money. So that'll be a line up. He gets $10,000 at the beginning of this period, and then has to pay back at the end of the 5th year. So here's 1, 2, 3, 4, 5. So here's the first year, and 1 represents the end of the first year. Here's the 2nd year period, and this hash line is the end of year 2. So this is the end of year 5. He's going to have to pay back some amount, and we don't yet know what that is. So some unknown amount is how he's going to have to pay it back. It turns out that if we put that into the formulas that we saw before, it is going to be $13,382. I saw you looking in the table, which is a good thing. You have these tables in your book, but just as a convenient reference, let me also provide them. Oh, that's not it. It's these. You can use formulas, or sometimes you can look up the interest amounts in these tables. And so, in the case of the man who is borrowing at 6% interest and it's compounding annually, okay, open up the table to the 6% chart. factor table I equals 6%. Okay, so what we have is we have a present and we want to find the future. So given P, find F. Okay. So this is F to P is the column that we want. So if you look at the F to P column for 5 years at 6%, what do you see? What factor is listed there? It's F to P at 6% interest, n equals 5. The factor is 1.3382. And so if we multiply $10,000 by 1.3382, we get $13,382, which is the same as if we had used the formula. And so look in the front part of this, it tells you it converts to future, given, present. It tells you the symbol for that symbolically, and then the formula. And so we could find that by the formula of 1 plus 0.06 to the 5th power, and that's how we would get this 1.3382, and then multiply it by the amount that was borrowed. So these tables can be a useful reference. That's how we do the cash flow diagram for A. Okay, let's look at the cash flow diagram for B. Annual payments of blank at the end of each year. So he got 10,000 and then has to make some payment here, here, and they're going to be the same amount every year, and there's 5 of them. 1, 2, 3, 4, 5. And so what that's asking is, we are given P, find A. Okay, so that is an A slash P at 6%, n equals 5. So if you look in the first part, you can find the formula for that. A slash P to given P to find A. So what does the formula look like? I, 1 plus I to the n divided by 1 plus I to the n minus 1. A little bit more complex than the other equation. And so if we did that real quick the manual way, 0.06, 1.06 to the 5th power, 1.06 to the 5th power minus 1. So will you calculate what the factor is with your calculators using this approach? We're going to need it to a lot of digits of accuracy.
Okay, point 237396. What more you can work with?
That's all we'll need because if we multiply that by the 10,000, so we want to find out what is A. So how much is it going to have to be each of these years? And so it was the original 10,000 times 0.237396. So it's going to be $2,373.96 each year. And if you turn to your table, to the 6%, the column that says A to P, you'll see that it's 0.2374. Okay. Annual payments of blank for 5 years, and then a lump sum payment of blank at the end of the 5th year. Okay, so what if it was going to be that there were going to be payments every year, and then also a lump sum at the end? Loans like these are not uncommon. Sometimes people will have an interest-only mortgage, and then the end of maybe 5 or 7 years, they'll have to have what's called a balloon payment. And so maybe they're just paying a certain amount each year and then a big balloon there at the end. So in this case, we wouldn't be able to know exactly how much they're going to be unless we knew either how much the annual payments were going to be or how much the balloon payment at the end is. And so this problem is what's called underspecified, because right now there are too many possibilities. But it gives you an idea of what the cash flow diagram looks like. All right, so I'd like you to try and draw a cash flow diagram. So someone's going to make an investment of $10,000, and this is from the point of view of the person who's making the investment. They invest $10,000, and then for 5 years, they get $53.10 every year. And then at the end of the 5th year, whatever it is they've bought, they're selling, and they get $2,000. And also, to complicate things, they have expenses of $3,000 a year for operation and maintenance. So draw what you think the cash flow diagram would look like for that. There are 1, 2, 3, 4 primary pieces to that. You don't actually have to calculate anything, just draw the diagram.
Can you have money going in and out in the same?
Yeah. In fact, in this case, we do. All right, Element, guide me. What should I draw?
First line you got there, down.
At 0. All right. Down. How long should it be?
For 10,000.
10,000 long? Okay. We'll say it's to scale roughly. This is 10,000 long. Okay, good. So $10,000 initial investment is down because that was cash going out. All right. What's next?
You put up for every 5 years for, I put 2,310.
All right. So you did the difference between the revenue and the costs of each year.
Yeah.
So you're saying the net effect is that you've got up 2310. All right. So we're going to say that this is 2310. And then what's the last part? Andrew?
Lump sum at the end.
The lump sum at the end. We'll show the other way. So at the end, they sell it for an extra $2,000. All right, so if we didn't combine it, then it would have looked like this. I need to bring in some other markers, I think. Okay, so 0, 1, 2, 3, 4, 5. Okay, the $10,000 that is invested. It says it generates an annual revenue of $53.10, so we could draw up. $53.10. There is an expense every year of $3,000. That's down. 3,000. And then the last thing is that there is the market value of 2,000 at the end of year 5. So another 2,000 at the end of year 5. And so this graph on the left is just if we had found the net revenue or expense for each of the years. And so we could have combined this so that it was 4310. Just said like that, and so then this would be just one big line of 4310. And that would go to there. Does everybody see this? It seems pretty easy, but there can be some really complicated cash flow diagrams, and so it's a little bit of a like Sudoku, you know, like it's a puzzle trying to figure out how to put all of the pieces of the word problem into a cash flow diagram. You're going to get really good at it over the next couple of lectures. Okay, so these are the tools that you've got when you're doing your cash flow diagram Sudoku. You can convert between present value and future value. So find F when P is given. And so look how they express that in terms of the tables that I've just handed out to you. The first page on that table, find F when P is given. So the phraseology is a little bit awkward when it says converts to F given P. So find F when P is given. That's the top one there. So the way that they write that under symbol is F/P. And so you go to the column and you find the F/P. What that means is find F given P. Find/given. All right. So this is one of your tools, is that you're finding the future value of some amount now. And so if you have $10,000 that you're going to invest over at Huntington Bank, you're going to retire on this, right? This is your retirement. So Huntington Bank is where you've always had your money, and you're going to stick with them no matter what. And so you got $10,000, and you're going to save that for 50 years. N equals 50 years. Oh, actually, it compounds monthly. So what's 50 times 12? 600. But the interest rate is going to be, interest rate per period is 0.05%. Actually, it's 0.0005. These are so small that it's hard almost to keep track of how many zeros there are here. Calculator. So it was 0.05% divided by 100, okay, 0.0005 per period. Now we have to divide by 12, and so the interest rate per period, oh boy, okay, so 0.00, how many zeros is that? 5? 1, 2, 3, 4, 4, 1, 6. All right, so much are you gonna have to retire on if we do this? And so it is gonna be the $10,000, 1.000416 to the 600th power. At least we got that going for us. What's going to be the future value of that? Can you do the calculations for me? Because I'm dying to know.
20 zeros, is that 4?
4 0.
To the what?
The 600th power.
You can make $252. I mean,
So I'll have $10,252.
250.
I saved for 50 years. I made $252 interest. I better come up with an
I know what I'll do
alternative.
on the way home.
Opening a savings account, right?
That's 100 seconds.
Yeah. All right. Yeah, you could go out to Outback Steakhouse with that. Your big retirement dinner. Okay, so here's another tool in your toolbox. If you know the future value, this is how you convert it back to the present value. And so 1 plus I to the n power. And so let's say that if you wanted to have 50 years from now, if I wanted to have $10,000, and these interest rates are bumming me out, really, the 0.05% one's bumming me out. Let's say that instead of doing that, you bought a stock, and there are some stocks that'll pay a dividend, a consistent dividend. Electric companies, utilities pay pretty regular dividends. You can find one that has a yield of maybe 5%. And so let's say that it compounds annually. So n is 50. The interest rate per period, I is another dead marker. .05, and so if I wanted to have 10,000, if I have $10,000 in the future, what's the present value of that if it's 5% interest? So in other words, how much would you have to save now in order to have $10,000 in the future? So it's going to be the future amount needed, $10,000, and 1.05 to the negative 50th power. So how much is that? How much would I need to save in year 0 in order to have $10,000 50 years from now if I'm making 5% interest? $872, right? So if the interest rate is 5%, it's actually worth saving. So what we've just found is that we found that the present value of $10,000 in the future is $872
So that's over 50 years though?
over 50 years. Yeah.
Still proud.
That's a long time to save, isn't it?
Yeah, especially when you try to make that in a week.
Well, okay, so if you save, you're thinking about now, if you said you could save, make this in a week. How much could you save conceivably a week? If you put, instead of buying a coffee, if you forego a few of the life's little luxuries, how much could you actually save per week?
Right now, none.
None. $10, could you find $10 a week to save? Maybe.
If my wife will let me have it.
All right, so let's say if you save $10 a week, what would be the effect? Save $10 per week, and you put it into that same electric company stock, which is 5% yield, and we want to know 50 years from now, the future value of that 50 years from now. So N is going to be 50 years times 52 weeks per year.
600.
So is that 2,600?
Yeah.
So N is 2,600. I is actually 0.05 divided by, we have to make it 52, divided by 52 because it needs to be the interest rate per period. Okay, so the future value of saving $10 per week, what is 0.05 divided by 52?
0.000962.
1.000.
Okay.
Huh?
There's no one, but I'm.
If it's doing 1 plus I.
Okay, yeah, so that's what.
0.00962
Yeah.
to the 2,600 power minus 1 I, so 0.000962.
Well, mine, I thought, mine,
Oh.
you probably, that thing probably stopped.
$116,000. That's what you'll have at the end of 50 years if you save $10 a week. Let me show you something. Many of you have phones that can have applications installed on them. I'll show you an application that's installed on my phone. Let's see, maybe. And then, okay, this is a calculator application I use. Find balances. Okay, so I think I mentioned on one of the recordings I did that, oh, you're not seeing it yet, are you?
We were.
Was it up before?
Yeah, it was.
Oh, it's because my screen turned on, all right. So, RPN is kind of nice because you can see intermediate quantities as you calculate them. And so in this example, we had, for example, 0.05 divided by 12 plus 1. So, oh, no, did I type it in wrong? 0.05, got fat fingers, divided by 12.
It's 52.
Oh, 52, it's not 12.
It's just like each number.
105 is 52. 1 plus 2,600 times to the 2,600 power minus 1
Oh, my.
divided by 0.0009. 00 number 0.
Yeah.
0.962 divided by, and then 10 times. So, doing it in that notation can be useful because it allows you to see like what the result of this to the that power is, and then subtract the 1, and then divide by that, and then multiply by the 10, and so you can sort of keep track of what's happening in the solution as you do. That's one thing I wanted to show you is this is called reverse Polish notation. And most calculators don't have it because it's a little bit awkward to learn it at first, but then it ends up being nice to have because not only can you see the intermediate calculations, but also there's fewer keystrokes than if you type it in algebraically. If you want to download this application, it's called HP 48, I think. But there's one other thing I wanted to show you, is that it allows you to solve finance. And so let's say that N, in our case, was 2,600. And it's at 5% per year. And there are, it doesn't know that it thinks that you only pay on a monthly basis, but we're considering weekly. And so we would actually say, instead of payments per year equals 12, interest rate per payment period is actually what it is. So, okay, so 5% per year, and there's 52 payments per year. Oh, that figure strike again. Let's go back and solve. Okay, we had the future value that we know we're going to calculate that, and the payment, 0. The payment was going to be $10, right? So now we can calculate the future value, and it solves right for us. 116,000. You can't use your phone on the test, but if you want to go out and buy one of these calculators, they let you use that.
Can we use graphing?
Sure.
Okay.
I was just looking at this thing, it's got all those on it.
It's got those too? All right. Yeah, and so you can use it to confirm a solution. In the problem statement, I might say, show your calculations. I just don't want you to write the answer. You can certainly use that to verify.
This is the same as the book, though. It says PV and FV and all that stuff.
Uh-huh. All right, so if you don't have a fancy calculator, maybe you can download a fancy calculator app and save yourself the money. There's probably an application that emulates that calculator, I would guess. All right. So this is showing converting between present and future to present, and you've got the tables values of that. Now the weakness of the table is that they don't have interest rates for every conceivable interest rate. If you look at the factor table, it's got 12 and then it goes to 18. Well, what if the interest rate is 15%? Then you're left with no choice but to substitute it into the formulas that are given. You can't use the table method unless you have the interest rate for that interest rate that's specified in the problem statement. 5%, for example. We've just been talking about 5% interest, but it's not listed here. If you had, what if it is 6% annual interest, but it compounds monthly? Which table would you use? Would you use the 6% table? It's 6% annual interest that compounds monthly? You'd actually use the 0.5% table. There is a 0.5% table because these tables are for the interest rate per period.
What is the, like when it says P/G, what is it? It's almost opposite of what you would think it would be.
I don't know. Yeah, because it's saying, when it says P/G, that's saying find P given G. But it is the opposite of the way that they present it in that word way. All right, so you can go ahead and take a break, and when you come back, the in-class exercise that we're going to go through is a series of practice problems, similar to what we've just been looking at. Did I already give you the in-class exercise?
No.
I thought I printed it. I don't have it
Give
here.
us the homework.
Yeah?
Give us homework.
Yes, I did homework. I haven't printed that in-class
What else
exercise.
class? We took Pearson's class before this one. Or probably it's a pre-req, sure. I don't know.
So we'll take a 5-minute break.
Is 111 a pre-req in this class?
No?
Just math.
No, just that.
On the test, all these formulas will be on the note part of it, or will we just have to memorize most of these formulas?
You don't have to memorize any of them. You can use that
Okay.
packet that I gave you on the exam.
As long as you bring it with you.
Memorize?
Don't forget your calculator. Did you do that to one of the first one of those exams?
Yeah. Cusick. No, I put none from my calculator and he took off 3 points. I was like,
PP water. And
I
CP.
didn't ask him, I wasn't reading my order. I was like,
What do you think that is? PPY.
Payments per year.
Oh.
I see.
What about CP?
CP line? I don't know. Try setting up a problem with that. Compounding periods per year.
Y'all are speaking Spanish.
343. All the, you know, like all the.
yeah, like, I always take the tools off the last shot, I can never get that headshot.
I did like the DMR though.
Like, I see their hands, that's like that big, and they still headshot me across the map.
All right, so here's the in-class exercise. There's 5 problems, and I'm going to be circulating around with the solutions, and you can check with me as you do them. There's no need for suspense or anything like that. This is what they call a low-stakes exercise. No need for students to get all clammed up on a low-stakes exercise. It's just for fun, just for practice.